Today we are doing the first day of lesson 7.3, triangles. Our I can statement: I can determine if side lengths form a triangle. I can construct triangles with given side lengths. So the first thing we're doing with our key idea here is classifying triangles. In this lesson, we are constructing different triangles and then we are classifying them. So these names should be familiar to you, or the majority of them should be familiar to you, but just as a quick review. When you're naming triangles, you need two names for each triangle. One name is going to be based on angles and one name is going to be based on sides. So you need one from each category. So angles. If all your angles are acute, it's an acute triangle. Acute means less than 90 degrees. If you have one obtuse angle, so one angle that's more than 90 degrees, that's an obtuse triangle. A right triangle has one right angle. And then if all of the angles are congruent, that's called equiangular. It's also a type of acute, because if they're all congruent, they're going to end up being 60 degrees each, which is acute. So acute, all acute, obtuse, one obtuse, right, one right, and then equiangular, all the same. Those are the angles names. All right, and then to name it based on sides, you're looking for how many congruent sides there are that have the same length. So scalene triangle, there are no congruent sides. All three of the side lengths are different. And in a triangle, the number of angles that are the same also matches the number of sides that are the same. So if it is a scalene triangle, none of the angle measurements will match because none of the side lengths match. Isosceles triangle has two congruent sides. So they mark these little line segments here to indicate that those are the same length. Isosceles triangles also can have two angles that are the same. So two sides are the same, two angles are the same. And then equilateral, that means all three sides are the same. And as a result, all three angles are the same. And you can either do equilateral, equiangular, those two will always be paired, or you can have equilateral acute, because an equilateral triangle does have all acute angles. All right, so for the first type of problem here, we are classifying the triangle. So we're just taking a look at the sides and angles and naming it. All right, so for A, I have 115 degrees, 25 degrees, 40 degrees. That is going to be an obtuse triangle. Because it has an obtuse angle, 115 is more than 90 degrees. These are also three different side lengths on here and three different sizes of angles. So that means it's going to be scalene. So it's obtuse and scalene. You don't have to write the word triangle. You certainly can. You do need to make sure you have both a name based on the angles and a name based on the sides. All right, B, we've got two sides that are the same, and then these two angles, the little red marks here, tell us that those angles are the same as well. So because we have two equal sides, that's going to be isosceles. And then we have all acute angles, so it's going to be acute. Isosceles, acute for that one. Okay, go ahead and pause the video and try these next two on your own. All right, number one, we've got a right angle, which makes it a right triangle. And then it's also going to be isosceles because we have two equal sides. And then number two, it's equilateral. All the sides are the same. And then we can either say equilateral acute because all of the angles are acute, or you can say equilateral and equiangular. So either one is equally correct. All right, so for our next one, determine if the side lengths form a triangle. So in order for side lengths to form a triangle, we have to add the two smaller sides. I'm going to write sum of smaller sides has to be greater than the longest side. And that's because you need to have them long enough to connect. So for example, if I was going to do, I'll just do one down here. I have two little tiny sides, and then I have like a really big side. That's not going to be long enough to make a triangle. In order to make a triangle, my two shorter sides need to together be longer than the longest side. Okay, so if the two shorter, when you add them together, it equals that side, it's just going to be one long line. If it's less than that, it's not going to stretch far enough. You have to have two shorter sides add together to give you something longer than your longest side. Okay, so what we're going to do on these is we're going to figure out which two are the shortest sides. So like for A, 2, 7, 6, 2 and 6 are the shortest sides. And then you compare to see, are they greater than your longest side? So here 2 plus 6 is 8. 8 is greater than 7. So yes, you do need to show the math support to support your answer. You can't just write yes or no. Okay, B, 11, 6, 18. We're going to add the two shorter sides. 6 plus 11 is greater than 18. 6 plus 11 is 17, is greater than 18. No, that's not true. 18 is greater than 17. Okay, go ahead and pause the video. Try these next two. All right, let's check our answers. So here for number 3, my shorter sides are 8 and 4. It's greater than 12. 8 plus 4 is 12. 12 is greater than 12. Nope, 12 equals 12. So it's not a triangle. It's just a straight line. All right, let's look at this one. So 5 and 7 are my shorter sides. So 5 plus 7 is greater than 9. 5 plus 7 is, whoops, it's not 11. 5 plus 7 is 12. 12 is greater than 9. Yes, that is true, so it forms a triangle. All right. This next one, two sides of a triangle have the given measures. Find the range of possible side lengths for the third side. So here's what we do. We're going to add, and we're going to subtract with our two numbers to figure out what the longest could be and the shortest could be, so that our two smaller ones equal more than the biggest one. So let me show what I mean by that. So for here I have 8 and 6. I add with the numbers. 8 plus 6, that's 14. And I subtract with the numbers. And you should just subtract in a way that's going to give you a positive answer. 8 minus 6 is 2. So here's what I write. 2 is less than x, which is less than 14. It's called an compound inequality because it's got more than one inequality sign in there. That means x can be bigger than 2, so like 3 plus 6 is 9, that's bigger than 8, but it also has to be less than 14, because once you get to 14, 8 plus 6 would be the small numbers, and it's got to equal something more than, it has to be bigger than our last one. So 14 would give us a straight line, but if we had 13, 8 plus 6 would be greater than 13, so that would work. So this is our answer right here. 2 is less than x, which is less than 14. So anywhere in that range could be our third side of the triangle. Let's try B. We're going to add and subtract with our numbers. So 10 plus 7 is 17. 10 minus 7 is 3. So my answer is going to be 3 is less than x, which is less than 17. Any number in between 3 and 17 would work for the third side of the triangle. Okay, go ahead and pause the video. Try these next two. All right, so let's go ahead and try this one. Okay, so we have 7 and 8. So we're going to add them and we're going to subtract them. 7 plus 8 equals 15. 8 minus 7 equals 1. So our range is 1 is less than x, which is less than 15. So somewhere in between 1 and 15 would be our third side. Okay, for number 6, we're going to add and subtract with the numbers. 9 plus 11 is 20. 11 minus 9, remember we always subtract to get a positive answer, 2. 2 is less than x, which is less than 20. Okay, and our last one here. Sketch a triangle that is A, right isosceles, and B, obtuse scalene. Label the sides and angles. Alright, so go ahead and pause the video. Try this on your own. Alright, let's check these. So A, right isosceles. We need a right angle. So that part should be marked. When they say label the angles, that's what they mean. Okay, and then isosceles mean these two sides have to be equal. Okay, so it's going to look something like that. If you figured out angles on this one, a right isosceles is going to have, these two are going to be equal. They end up being 45. I'm not looking for angle measurements here, but something that indicates these angles are the same. That is your right angle, something like that. Should be in your picture. Okay, B, obtuse scalene. That means there's one angle that's more than 90 degrees. So I'm going to go ahead and do that angle first. And then our side lengths have to be different sides. Ooh, I didn't actually label these. I just kind of did little lines. So let me go back. We'll say 5 inches, 5 inches, and let's see, this is 10. So I need a number smaller than 10, but it's our longest side. I'll give it 8. All right, here's our obtuse angle. Let's see, I'll label that one. I'm just going to pretend it's 120 degrees. Again, we're sketching, so it's not going to be exactly equal. And let's see, I have, I'll make my biggest side 10 centimeters. Okay, and then let's see, I'll do 2 centimeters. I need something that's going to add to give me something more than 10, so I guess I'll make this one 9. So I've got labels here on our side. So that's obtuse scalene. All of the side lengths are different sizes. All of the angles will end up being different sizes, and the obtuse angle is more than 180 degrees.